Yeah, so it gives me just enormous pleasure to be able to introduce my friend and colleague to you all, Tabbetha Dobbins, who is a physicist at Rowan University and also the VP for Research and the Dean of the Graduate School. Tabbetha got her bachelor's in science and physics from Lincoln University in Pennsylvania, and her graduate degrees, or MS from the University of Pennsylvania, and her PhD in material science and engineering from Penn State University. She's a materials scientist who specializes in composite materials, but importantly for the topic that we'll be discussing over the next 4 days, she was a colleague of mine on the American Institute of Physics Team Up project and has really taken the findings from that project and done some really important and interesting subsequent research about the effects of COVID on African-American students in the context of what we learned in Team Up. So without any further delay, Tabbetha, please take it away. And thank you so much for coming today.
Well, thank you. Thank you everyone for attending. And let me just share screen and get my slides projected. I do want to thank you, Bo. Thank you to the entire MC team for thinking of me as a speaker for this event. I want to thank Marissa, Matt, Justin for the work that you've been doing in paraDIGMS, and also for considering me to be invited for this talk. Give me 1 second to get, I like to get the gallery view on the side screen so I can see your reactions if there are any. So as Bo pointed out, the American Institute of Physics convened a task force to look at the persistent underrepresentation of African Americans in the bachelor's, in completing the bachelor's degree in physics. We confined our studies to the bachelor's degree and to Black/African American impacts. But the findings from the study can be more generalizable, applied to other STEM disciplines, and also applied to a broader set of demographic groups that may feel disenfranchised in their discipline. So I hope I can give some remarks that will be relevant and useful to the work of paraDIGMS. And the Team Up report, the QR code to the report is here on the front page. Now, this is the Team Up members, as well as the American Institute of Physics support team. And the key thing I want to point out here with this team, this illustrious team, I've really enjoyed working with them over the years, and we continue on working together through report outs like this one and through further projects that I'll describe at the end of my talk. But the thing I want to point out is that it was a very wise choice that the American Institute of Physics made to pair physicists from a variety of different institution types, from HBCUs to 2-year institutions, 4-year institutions, R1 institutions, and so forth. But not only pairing physicists of different institution types, but also pairing us with sociologists. So you can see in my color coding, I may have lost my my color bar here, but Mia Ang and Sharon Fries-Britt are both sociologists. And one of the take homes that's so important is that if we want to institute change, it's important to look at the groups of people who are expert at driving change, at studying societies, at understanding how societies form, how they decision make, and how they adopt and accept change. And then, of course, you see the AIP members listed here, including Bo. And then finally, we wanted to enlist one more sociologist, and we tapped for Simone Hayter-Adams, who was at that time a graduate student who could do some more of the sociology work. And so so it's also important to be flexible in your team as you're developing this kind of work, and make sure that you're looking for who's not in the room and what other skill sets you need in the room. And so, so I think that the first thing I want to point out is that there are some commonalities between the American Mathematical Society's report from 2021. That report was titled Towards a Fully Inclusive Math Profession report, and the Team Up report. And so some of the similarities are that they are focused on creating successes for Black students in the relative discipline. Both reports honor the role of HBCUs in producing Black scholars in that discipline. So when I say that discipline, we're either talking physics or mathematics in these cases. And they both took an approach which centered the population or a group and centered that group as in a positive light and a strength-based light. And so, they both aim for sustainable change, not the one and done initiatives that we're all very familiar with. They both, and it's very important when you try to drive systemic change, to address leadership and structures and how those levels can participate in the change. And both reports center the voices and experiences of the Black scholars in those disciplines. And so this is something you'll see in the AMS report and towards the end of my presentation here, or if you go to the Team Up report directly, you'll see these voices and experiences centered in the work. And I think that's also a key to driving sustainable change. And so the charge to the Team Up report issued by the American Institute of Physics was to examine and assess the reasons for persistent underrepresentation of African Americans in physics and astronomy at the bachelor's level, and to produce a report with evidence-based recommendations for AIP member societies, physics and astronomy departments, and other stakeholders to increase the number and percentage of African-American students obtaining the bachelor's degree in physics and astronomy. And so I'm going to go into some of the findings out of the Team Up report that it gives some examples on how to use the report. What you'll find with the Team Up report is that it's very comprehensive. You can read it from front to back, but I find it very useful to present various case studies and then look at how the report findings can be used to address those case studies. So you'll see that as the way that I present the report in this work. And so overall, what we want to know is what matters most to making sure that we retain and contribute to increasing the numbers of African-American students majoring in physics and astronomy. And as AMS and paraDIGMS would like to increase the number of African-American students, graduate and undergraduate, persisting in mathematics. So the report was released. We started the work in late 2017. And we had our first meeting, I think it was November, December of 2017, where we began to just describe how we would like, what activities we would like to undertake and how we would like to go about it. And the report was released at the AAS meeting on January 5th of 2020. And so the report highlighted 5 factors that are important to increasing persistence of African-American students in physics. The first is belonging. Belonging is determined to be essential for persistence. Physics identity. Physics identity is the quality where the student themselves sees themselves as a physicist. And that can happen before the bachelor's degree is attained. And I'll talk a little bit about that in the case studies section. It's important to have good academic support, and that means effective teaching, good pedagogy in teaching, having mentoring available, tutoring available, and student-centered support. These types of supports are crucial for student success. But not only academic support, but personal support. So the population of students that we are working with and talking about are typically having additional financial burdens, sometimes additional family pressures to make sure that their income, while they're even a student, is contributing to the family's overall budget. We meet students here at Rowan in that situation all the time, where they are responsible for making their contribution to ensuring that the electricity is remaining on at home. home, or we meet students who are responsible for the younger siblings in the family and things like that. So this is something where personal support is needed to offset these types of financial burdens and stress. During the course of our work, we met students who were working full-time, something like 30 hours a week on a job outside of campus, in addition to pursuing the physics bachelor's degree. And then finally, the important aspect of addressing leadership and structures to create supportive environments, policies, and really addressing the systemic change that's needed. So this report was released at the AAS by Jedidah Eisler, who was on the Team Up team, and Ed Berchinger, who was also one of the co-leads of the Team Up team. And the report was well received, as you can imagine. But looking at the date of January 5th, 2020, we didn't realize that we would be faced with so many challenges just a couple months later due to the pandemic. And so later I'll talk about some later work that we are undertaking and still ongoing to look at whether these 5 factors were still able to be supported in the conditions of the pandemic. So what the Team Up report brings is new excitement around the topic, as the AMS report will do and is doing, most likely. And so so we can see how other groups can play a marked difference. The topics for the report targeted mentor training, for example, and also used asset-based approaches to mentoring for student support across cultures. So you can teach your mentors how they can be more supportive across cultures, and also understanding what are these counter spaces. This was a key concept in the work of Mia Ang, also one of the sociologists on the Team Up team, to talk about the fact that the faith-based organizations are counter spaces. The intramural sports team are counter spaces. And in these spaces, the student is able to help develop their identity in the discipline, either as a mathematician or as a physicist, as the resident expert on that topic, if it's in a faith-based group or organization, or in the intramural spaces where they really find their presence on your campus outside of the department. So these are what we're calling counter spaces. And the report points to a need to raise a $50 million endowment from foundations and individuals to support students with unmet financial needs. And we're happy to say that 2 years later, we're making progress along that road as well. And so just a little bit about me as a faculty member and a mentor to underrepresented students. I have been before I was vice president for research, I was in the physics department for many years, where I had the opportunity to mentor students from diverse backgrounds and even see some of those students off into graduate school. The photo that I'm pointing to, I hope you can see my pointer. These are 2 of my students, one from Grambling State, one from here at Rowan, who went on to University of Missouri for graduate school. And the third one from Rowan University wasn't there that day. And I was able to go and present there in their graduate studies environment. Now, all of 3 of these students are doctors. And so this is so wonderful to have a track record of mentoring students, whether they're in my lab or not. I tend to make sure that the students actually get to the counter spaces, things like the QMIP meeting, similar to QWIP. This is a conference for undergraduate underrepresented minorities in physics that was held at the University of Maryland for multiple cycles. And so these opportunities are so important when students are building their own physics identity, or can I say math identity as well. And because of my topic of research is synchrotron X-ray studies, I'm able to take my students to professional experiences where they're in a lab with PhD scientists, and they're really getting steeped into the experience of being a scientist and the environments there. And so this is part of my journey and why I'm so passionate about this type of work. So So some of the ideas that are made from the report, the recommendations for the departments from the report are that departments should adopt policies and practices that encourage multiple faculty, including those who are not members of marginalized groups, to engage in formal and informal mentoring. This is where you saw on the prior bullet where I talked about engaging faculty members with competencies where they can mentor across cultures and be comfortable doing so. Another recommendation for the departments are that lone champions can make a big difference for students, but we really did want to emphasize in the report that lone champions it's an unsustainable effort. We really need, if we want to have sustained change, we need the entire departments involved. We need the entire institution involved, and we need everyone moving in the same direction. You can imagine if a lone champion leaves or retires or simply changes their shifts their focus in a different direction, then the sustained efforts can be lost. And then for professional societies, and the AMS report also does make a lot of recommendations for its own professional society along the pathway. But for professional societies, support mentorship and help faculty members by shaping the reward system. So what's meant by that is that oftentimes faculty members are going for tenure if they're pre-tenure. Even if they're post-tenure, they have to apply to get from associate to full. And oftentimes this type of mentoring and this type of support doesn't lend itself to helping the faculty member to move through their own ranks. What professional societies can do is to reward faculty for excellent mentorship and help the faculty member through that reward system with meeting the goals and metrics that they have for themselves personally. And so this is important. So now I want to turn to a case study because you can see the report is very comprehensive. I just gave a few highlights, but now I want to use a case study to describe a faculty member who has an interaction at a PWI with having a Black undergraduate student in their department and in their physics class. So I'm going to give you guys a few moments to read this and take it in, and then we're going to dissect it and look at how the team up recommendations would be able to impact and guide that faculty member. So I don't want to give you too long and I don't want to give you too short. So I'm going to stop you here and I'm going to ask us to dissect this statement. It's a scenario, but it can be helpful to us to sort of see where the report that can have some impact. And so what do we know from reading this scenario about the student? We know that the student is at a PWI and is the only Black student in the class. In that classroom or in the whole department. We know that the student is a freshman, and we've met students like this who are the only Black student in their entire department. When we go to the QMIP meetings or to the National Society of Black Physicists meetings, we often can find students who have come from a department where they were the only one. We know the student is a freshman in the first year. We know that the student doesn't spend time in the department outside of class, coming to class, but doesn't spend more time in the department. We know that the student doesn't work in groups. And we know that this professor, though, sees that the student has potential and needs to connect with other students and departmental resources. And the professor is asking, what can they do to help? Now, what do we know about the professor? So about the professor is a junior faculty member. They're just a second year faculty member. We know that they're observant about who they see in the department and who they only see during class periods. So that's a key when we talk about faculty members being mentors. It's important that they are noticing how their students are spending their time, aware the environment. So that professor has a tap on the environment or understanding of the environment, and the way that they see other students in the department. They can see a difference there. They notice that even during class, the student works alone. So they're able to see where there needs to be some intervention. And their grading scale is fair, but they still think the student has potential. So their grading scale is saying 60 to 70%, but the student has potential to even do better. They see this gap of not working with other students and not spending time coming for help and things like that. And they also, this is another thing that's so very important, that even the junior faculty members in your department are understanding what resources are available to offer to the students. And so when they ask, what can I do to help, having even the initial first year, second year faculty members familiar with the resources that are available is going to be important. So let me move a little bit quicker so that we have a lot of time for Q&A. But the report itself is research-based findings and recommendations. We interviewed departments, and these are for individual faculty members, departments, and professional societies. The research that we did is that we did student surveys, we did interviews at the National Society of Black Physicists Conference. We also did site visits to departments that were performing well at completing Black physics, at issuing bachelor's degrees to Black physics students. And before the driver that AIP used to really identify the problem is shown here. The data just shows that the number of bachelor's degrees earned in physics have been on an incline since 1997 or so. But if we look at the same time window for African-American students in physics, that the incline is not as steep, is not nearly as marked as the general incline for pursuing the bachelor's degree in physics by all groups. We also know that if we compare other disciplines, not just physics, but the other STEM disciplines, we can see that, again, the physics is this black line and it's quite flat going over the same time period of 1997 all the way up till 2017 when Team Up Task Force first convened. And so we were driven to undertake this work. And so now here are some of the ways that the findings are represented in the report. From the surveys, the students were able to identify themselves as either white, other, mixed, Black with mixed race, or African American. And so Black with mixed race meant Black in any other combination. And so as you look at these statistics, what you can see is that when students are reporting to have felt socially isolated in their physics classes or labs, those who responded to most times, we had a higher percentage on average of those responding to that question with most times for African-American students than we do for the other populations of students. When we ask the question, it is important to me to apply my expertise in my major to benefit the community I belong to, we see a major increase in the number of strongly agree respondents relative to Black, mixed race, or white. And so, so these were just some of the findings, but again, these were some of the survey outcomes, but again, we point back to these 5 factors of belonging, physics identity, academic support, effective teaching, that's academic support is your effective teaching, personal support, leadership and structure. And we thought it was important to put a topic of change management into the report to sort of guide people to not only have the information of what factors are important, but how do you drive systemic change in order to solve such a persistent problem. And so I'm just gonna start rounding out before I come back to the how the professor can answer the question of what can I do to help. I'm gonna give you some other results and findings. These are quotes related to belonging, physics identity, and other areas that were there in the report that came out of the either the survey or the interviews with students. One student says the climate of the physics department is very non-inclusive of people of color. They would say things like, you should change your major. There were certain times in class when the professor would pose a question and I would have the answer. Then another student in the class was present and happened to be a white male and would be like, no, that's not right. So I didn't propose my answer to the full class. I was embarrassed because I was like, I'm just going to get it wrong. But I ended up being right. Just things like that where your colleagues and other students around you make you feel more doubtful. I'm trying to work around that and still have confidence despite their opinions. Now, this is something that we mentioned in the Team Up report. I think I'll get to some of these findings of the peer-to-peer interactions can also be very impactful to that sense of belonging and that sense of identity. So along the lines of physics identity, this student says in this quote, I've had 2 professors ask me why I'm in physics. They see how much I'm struggling and they say like, why are you still a physics major? Why do you want to do this? They've said this multiple times. It's like, well, I'm here because that's what I want to do. And they're like, you're making your life difficult doing all this. It's just very discouraging when you hear this. And so we all know that pursuit of a STEM discipline oftentimes leads to a lot of professional satisfaction. It leads to financial, these are some of the best majors financially when students are graduating with a degree in this field. And so being discouraging to the students about the major is quite damaging. When it comes to academic support, here is a quote that was selected. There was one teacher that really honestly, I was going to give up on physics, and she changed everything. I mean, she was so passionate about teaching and she knew a lot about physics education and research. She kept checking on me and she would make comments like, this is not so good, come see me. Then she would email me and say, did you see my comments? Come see me. Now, this gets to the academic support and really good pedagogy. So the workshops that you sponsor, for example, for faculty members on teaching and learning, those types of workshops can make a huge difference to the population of underrepresented students and of marginalized students. Just using and knowing how to use excellent pedagogy can make a huge difference. And so, so here, looking back at those scenarios that I just played, and we'll wrap up with the case study that you guys read. But looking back at those scenarios, factor 1 on belonging, key finding 1D, there were 4 of those findings. Again, the report was very comprehensive. So what I like to do is kind of walk through with these types of examples and see how these findings apply. Microaggressions and discrimination received from peers diminishes the student's self-efficacy and persistence. And so classroom, student clubs, and common spaces and departments should have clear and established rules of engagement. I like how you put up the conference rules into the chat at the very start. These are the types of rules of engagement that we need for our common spaces, our physics club room, the club itself, and the department as a whole. And these should assure that everyone is welcomed and valued, and convey that inappropriate behavior will not be tolerated. And so I'll let you read the rest of that in the report. In terms of physics identity, finding and a recommendation. Finding was that participation in research, attendance and presentation at conferences, and even working as learning assistants. I'm not sure if you guys have the learning assistant programs in mathematics where the students go into the classroom as a sort of teaching assistant, but they're going in at the undergraduate level to help the student groups sort of during the problem solving, the in-class problem solving session. All of those foster physics identity development. And I want to point out that physics identity development is not just done in the department, or math identity, not just done in the department. As I've gone out and presented this work, what I've found and what I've met are students who report that after in their, for example, faith-based organization, they mentioned that they're a student, that they're majoring in physics, that the community in that faith-based organization looks to them for the answers when it comes to something that seems like it may be science or physics or otherwise. That also fosters that sense of physics identity, but it's done in one of the counter spaces. So I just wanted to point that out. But done formally, making sure that your students are able to participate in research, they're able to present at conference, they're able to attend conferences, they're made comfortable to ask questions, participate in the Q&A at conferences and things like that. That's also important. And one of the recommendations related to physics identity is that departments invite speakers who demonstrate research expertise on physics identity development and work with faculty on evidence-based ways to strengthen students' sense of physics identity. Coming to the third factor, one of the findings, and this is out of 4, and one of the recommendations, so this is just to whet your appetite for diving into the team up report. Overall, student success increases with the number of committed and caring faculty in the department. And this goes back to not just having the lone person who tries to drive all the systematic change themselves. That can feel like it's an accomplishment, but you really need to have a higher number, if not all faculty in the department who are committed and caring. When we were preparing the report, we struggled with whether to use the word caring. It seemed to be such a non-physics word, but as we went about our site visits to the institutions that were performing well, we noticed that this is a true aspect, this aspect of caring. It's really something that really makes a difference. And you saw it in the positive statement. I mentioned it along the lines of pedagogy, where the professor said, come and see me, and really reinforced the message of, hey, you didn't do so well, come and see me. And so this is a caring action. It is important that faculty who are not members of marginalized groups also be engaged in these efforts to show students that they are valued. And again, earlier I mentioned the training, so that faculty members can mentor students from other demographic groups. And so this type of training to make sure that faculty members are comfortable discussing and mentoring across demographic lines is going to be so important. And one of the recommendations along the academic support is departments should adopt and encourage multiple faculty members, including those who are, I think I read that already, not members of marginalized groups, to participate in formal and informal mentoring. Okay, I might have had that written in 2 separate places, or I either read it twice. Okay, coming to factor 4, finding and recommendation. Student retention improves when faculty members recognize students as individuals with unique and intersecting social identities and experiences, such as being a first-generation college student or working to support a family. And I mentioned this at the outset. Your students walk into the classroom with their own identities, and especially with graduate students, they may walk into the classroom with not just just a family structure that is one that they grew up with, and they're now a child contributing to the economics of the whole family, but they actually may, as graduate students, have families themselves, spouses and children to take care of themselves. It's so important to recognize these intersecting identities and experiences, and these can also benefit your program to recognize these various identities and experiences. When you want to, for example, have a workshop for young kids, well, one of your students who is a parent would probably know how to relate, how to organize that workshop, how to engage younger kids, because they have younger kids. So really bringing the social identity and the experiences of the students to that being a welcoming aspect, and not just treating them like a mathematics robot or a physics robot to only do these tasks that are associated with the discipline. And recommendation, faculty should seek funding for undergraduate students to work in research. Again, as learning assistants, in some ways that can be paid at my institution, that's sometimes paid learning assistants, and otherwise help them find ways to academically advance while earning money. The example I'll give here is, pardon me, the example I'll give here is a underrepresented student who wanted to go into the medical professions. And the student works nearly full-time off campus, but works in a pharmacy as a pharmacy assistant. And in that way, that student is reinforcing, even though they're doing it to earn, because of the type of job they were able to find off campus, they're reinforcing their STEM identity in this case. And then leadership and structures. Again, this one tackles the lone champions, making sure that we don't put everything onto the lone champion. It's important that a significant fraction of the faculty consistently participate and demonstrate that they value and support underrepresented students. The department chair should provide incentives and rewards to multiple faculty members, including those who are not members of marginalized groups who actively support underrepresented students. So let me round out with the case study where the professor asked, what can I do to help? And had that professor read the team up report, he or she would find some of these bullet points there, that the department should have common spaces. They should publicize those common spaces and regularly reinforce the rules of engagement to ensure that everyone is welcomed in those spaces. Suggesting seminar speakers who can talk about physics identity development to make sure that the student who comes into the environment, such as the student in our case study, the environment itself, the people who are already present in the environment, understands the importance of physics identity development, or in your case, math identity development, and is ready to pursue activities and things that will help enhance that. That's so important to the student's persistence. And inform students about learning assistance and research opportunities. At my institution, the students will not be able to become learning assistants, or much of the time go into the research labs until their sophomore year, but this is still something to talk to the students about early enough. Learn about informal mentoring. The faculty members can learn ways of adopting informal mentoring, of recognizing the students' unique social and intersecting social identities and experiences, and help engage that student to show them that they are valued in that setting. Departments can improve incentives and rewards. Much of this, as I mentioned, is untied to tenure. So faculty can feel pressured to choose the very the students who are earning A's to come into the research lab with them, rather than the students earning 60 to 70%. my institution, I'll just use a personal example. My institution, listening to some of these senior faculty members who were here when I got here, they really emphasized that we want to bring the students with the 60 or 70% into our research lab, because oftentimes for the student to get employment after they graduate, it's the research experience, it's the practical experience that helps their resume stand out rather than the transcript. And so they had seen it, they had been here for a while, they had seen it play out again and again, that these 70 or so students, 70 percentile students on their C students, is what I'm basically saying, are able to then get gainful employment, because when they interview, they're able to talk about practical experiences that they got in the lab. So making sure that that kind of message is disseminated out. And then professional societies could provide training on an asset-based mindset so that we can have improved mentoring across cultures. And so everyone should realize that this is a team effort, and this is just a quick summary slide of all of the aspects that we talked about, including the change management, and where various stakeholders in the process can play an important role there. So just to leave you in summary, the time is now, and this is the overall statement for our report. The persistent underrepresentation of African Americans in physics and astronomy is due to a lack of supportive environment for these students in many departments, and the enormous financial challenges facing them. And I want to just emphasize a work done by, I think it's Duke University Professor Sandy Darity. He's an economist, and he studied the racial wealth gap. And if you just Google those terms, racial wealth gap, you'll find that there is this persistent difference in average household wealth, not income, but wealth. And those are two different terms. And I delved into that work a little bit more because of this statement about financial challenges. I wanted to understand it a little better. You can have a high income, but we have these persistent historical disadvantages that have led to a wealth gap. So that results in many students having enormous challenges facing them. And so the programs have to really understand that for these students to be successful, they may be taking jobs at 30 hours a week outside of the department, outside of the university. One of the things that I found encouraging when I went on a site visit and met a student working 30 hours a week just to be able to support themselves or their obligations, I found that the student said, well, I'm a C student, but I know I could have been a B+ or A student had I not had to work the 30 hours a week. Well, sometimes that's pretty much, that can be an answer, that positive reinforcement to say, hey, these are the circumstances, but we know that it doesn't play into your value as a physicist coming into the community, either going into the profession or going into graduate school for this topic. So solving these problems requires addressing systemic and cultural issues and creating a large-scale change management framework. So I'm going to stop here and just say a few words that I think are important about ongoing beyond the report. You guys have the AMS report. The title of it is Towards a Fully Inclusive Mathematics Profession Report. Now, that's a very strong report. It's evidence-based findings, but what I find possibly is a difference, I'm not in the math community, so I can't say if this is a difference, is what follows the report. The Team Up report was able to be followed up, and this is through efforts of American Institute of Physics. This is also through efforts of various donors and foundations, but the Team Up report was able to be followed up with implementation workshops led by AIP. And what this did is it cohorted groups, and some of you may even have been involved, cohorted groups of universities to spend some 9 or 10 months coming to workshops on a periodic basis to really figure out how they can implement some of the findings in their specific setting. Again, as I said, if you read the report from start to finish, you'll find it to be very comprehensive. It handles a variety of case studies. So now implementing something that is on an ongoing basis where someone can learn how to implement some of the findings in their particular setting is so important. There is another piece of work that is led by the American Physical Society called IDEA, and it focuses on the change management aspect. And sometimes you had teams who applied for and became part of the implementation workshop teams, and they also became part of the APS IDEA change management workshops. There were fewer workshops associated with that, but still equally as effective and ongoing. And then I led a NSF proposal, an NSF rapid proposal to try to look at the effects of the pandemic on the persistence of the team up findings. And we're right in the middle of revisiting the 5 site visit institutions from the team up report with a set of questions and inquiries about how they were able to continue to be supportive to African American and Black students during the pandemic, and what were some of the differences there. So the key takeaway is for the AMS report to really continue the trajectory, to continue it with either some implementation workshops with various campuses, to continue it with a fewer set of workshops that are focused on taking the ideas and focusing up on how do you drive change management at the top of the institutions, and in other ways, to continue with the work, even with presentations like this one, presenting out the work on a continuous basis. This is going to be very, very important to next steps for your disciplinary, the report from your discipline. So I'll leave you here on this final slide and just say thank you. And you can read some of the faculty voices that of the site visit institutions that we visited. And I thank you for your time.
Thanks, Tabbetha. That was great. Can you hear me, Tabbetha?
Yes, I can hear you well.
Cool. Yeah, and we have some questions in the Slido, so we'll get to those right away before we get to the top of the hour. The first one is, do you have suggestions for encouraging faculty who aren't members of underrepresented minority groups to get involved? What sort of incentives are effective?
Yes. So the key here is I think I gave the advice to professional societies to really think about workshops instead of in partnership with an implementation workshop, to really do some cultural, cross-cultural mentoring types of workshops. I would say that's an idea for a professional society as a whole. For faculty members as an individual, I would point you back to the case study that we used in this presentation, where the faculty member just familiarizing yourselves with all of the resources that are available, with taking back the information about setting up a environment in the department, but also in the breakout spaces of the department that are inclusive and welcoming, and also other small things like improving on your own pedagogy, taking courses that helps you to form the groups. And if you notice, the student in the case study was never working in a group, and so really enforcing in classroom rules that lets everyone know, including whether the person felt excluded from the group, the student in the case study felt excluded from the group, or just chose not to participate in the group. Well, you can set some ground rules in your classroom that talks to everyone and basically lets everyone know that you're expected to be participating and welcoming to the group. Those types of things can be done. In addition to research experiences, taking the physics identity and the belonging factors, and as an individual, you can sort of elaborate on those in many ways.
Yeah, one thing that struck me from the report was that on the physics identity thing, there were two really important aspects to that. One was the student perceives themselves as being a physicist, but maybe even more important is that others perceive them as being a physicist. And that seems like one area where faculty can play a big role.
Yes, and sending the students out. Our students go out to high schools. They talk to Girl Scout troops. Our astronomy club was just talking to a Girl Scout troop last week, encouraging students to participate in that. Those Girl Scouts and those high school or middle schoolers really see your students as the expert physicists when you send or take the students out for those types of experiences.
Yep, thanks. Another question, how can instructors of classes with 200 plus students, especially common first year courses, effectively intervene to give individual students support?
Okay, so this is work that I want to say Zandria McCall. I'm forgetting her last name, but her first name is Zandria, Xandria. I saw her present on learning community work at a conference, the National Mentoring Community Conference. She reported on what's happening when you have a learning assistance. I didn't mean to say learning communities. When she put her learning assistants into a learning community where they would learn effective interaction across cultures. And so when you have a 200 plus person classroom, one of the best practices is that the students can actually do group work, problem sessions in breakout groups and small groups of 4 or 5, and that you have an army of learning assistants who are moving around the room, helping the groups to go through the problems, checking the work and things like that. Well, the intervention that Zandria's group looked at was in having those learning assistants come into a learning community setting where they learned about the mentoring across cultures. And so that can be an effective way to take this up.
So I'm guessing
in a large classroom setting.
In training learning assistants, it's really important that they get some training in cultural awareness as well. Okay, another question. The difference in the importance for white and Black students of bringing knowledge to their communities was large. How does this come up in student interactions?
Among each other, or student interactions with the communities?
I'm guessing that what each student sort of brings to the classroom, and you have Black students and majority students, for example, interacting, but they come in with different worldviews and experiences. Okay. So what are your perceptions on how this affects student interactions?
I would say that if that is a huge difference, and the Black students really want to impact their communities, that's where I would say having the physics club or the math club to go out into the community. Oftentimes we already have programs like that where they go out into the community as either tutors, or they go out for just giving demonstrations. We have all kinds of very cool demos, and our students go out and deliver those. Informing the students from underrepresented groups about these activities that are ongoing, if you know about them, and letting them be a part of that, but not only letting them be a part of that, they may actually drive the idea for what school you may go and partner with next, or what group you bring in into the setting for one of the experiences, one of the workshops or other types of experiences there. So what I want to say is that there, for the students who have answered very high on that scale, it's very important that we set up some immediate opportunities for those students to use their knowledge back in their communities, whether that's tutoring, that they become tutors, that they deliver workshops, or that we just give them a scope, for example, in the research lab of a problem, and how that relates back to their communities. I think those are some of the ways that can be addressed.
Okay, I'm going to ask one last question, just to make an attempt to tie this into the intent of paradigms, and that is, and also drawing on your own experience as VP for research at Rowan. So how do you think, I mean, even though the team up report was highly data driven, and we tried to make the findings and the recommendations all based on the data we uncovered over those 2 years. In terms of extending what was learned from team up to graduate education, I think particularly graduate admissions and then retention, like what are 1 or 2 or 3 important lessons that you might recommend for the math community along those lines?
Okay, so I think that we can, I'm not sure if we touched on this in the team up report, I'm just relying on my own knowledge. I think we can consider the impacts of using the GRE score, for example, for our admissions criteria, or weighting it heavier than the statement and the interviews. Those types of ideas are emerging. I know that Geraldine Cochran at Rutgers University has published work and does studies on the impact of the GRE and whether it's truly a measure that's important for success in graduate school. And so that just circles back to the entire idea of involving sociologists in the discussions and in the work, because what the core question of the sociologist is what is important as a factor to success. We often assume that we know what's important as a factor to success, but we may actually be just carrying from historical perspectives things that we saw as trends rather than those things really having an important impact on success. So that's one of the things I would say to answer that question. Then just going straight back to the 5 aspects, identity, we'll say math identity, a sense of belonging. Often if they're graduate students, they should come with a math identity already, but make sure that is established and in place. Sense of belonging, pedagogy, academic support, making sure that they have adequate, even at the graduate level, academic support, personal support, and that includes accepting them as the well-rounded being that they are when they arrive into your setting, and then leadership and structures, and really making sure that from the top down, all of the things that you have looked into and recommend are able to be accepted from the top down, including things like looking at the impact of the GRE and the ideas around the bias and the bias that can be in the exam, or around the stereotype threat that can be associated with these kinds of exams.
Okay, great. So we need to go to the breakout rooms. So before we do, let's give Tabbetha 1 round of applause, either in the screen or
Thank
whatever.
you. Thank you all.
Yeah, that was really great. Thank you.